The universe is far bigger than our minds can comfortably hold, and yet every discovery we make pulls us deeper into its mystery. Before us stretches a universe so vast, so mysterious, that even our boldest imaginations barely scratch its surface. Today, we're diving into the top 10 most astonishing facts about the universe. Revelations so extraordinary they reshape our understanding of reality. Buckle up, because the deeper we go, the stranger and more breathtaking the universe becomes. Number 1. How big is the actual universe? Let's begin with the fact that the observable universe stretches 93 billion light-years across a scale so vast that even light, the fastest thing we know, would need unimaginable spans of time to cross it. We're talking about a scale so enormous that it defies human intuition. A light-year, the distance light travels in 1 year, is already staggering, about 9.46 trillion kilometers. Now multiply that by 93 billion, and you get a number so large it's nearly meaningless to the human mind. Yet that is the diameter of the cosmic bubble we're able to observe. But here's where it gets even more interesting. The universe is only about 13.8 billion years old. So how can we see objects farther away than this? The answer lies in the relentless expansion of space itself. As light travels toward us, the space it moves through is stretching, carrying galaxies farther and farther away. So the light we see today from the most distant galaxies began its journey billions of years ago, when those galaxies were much closer. By the time the light finally reaches us, the galaxies have been pushed out to an immense distance, so immense that the observable universe now spans 93 billion light-years from edge to edge. And that's just the region we can see. Beyond that cosmic horizon likely lies an unimaginably larger, possibly infinite expanse we will never detect, because the light from those distant realms will never reach us. Space is expanding faster than light can chase it. In other words, the universe is not a fixed structure. It's a constantly growing bubble of visibility, surrounded by an ocean of the unknown. What lies beyond it may be stranger, larger, and more complex than anything we can conceive. Number 2. The mysterious force tearing the universe apart. When astronomers first discovered that the universe is expanding, it was surprising enough. But the true shock came in the late 1990s, when 2 independent teams of scientists realized something far more unsettling. The expansion isn't slowing down, it's speeding up. Galaxies aren't just drifting apart. They're being pushed away from each other with ever-increasing force, as if some invisible hand is stretching the fabric of space itself. This mysterious driver of cosmic acceleration is what we call dark energy, though the name is really a placeholder for our ignorance. It isn't energy in any form we understand. We can't bottle it, test it, or observe it directly. Instead, we detect its presence only by the effect it has on the universe on the largest possible scales. It acts like a kind of negative gravity, a repulsive pressure that counteracts the pull of matter and pushes space outward. What's even more mind-bending is its sheer dominance. Dark energy accounts for about 68% of everything in the universe. Let that sink in. Nearly 3/4 of the cosmos is made of something we cannot explain. A further 27% is dark matter, also invisible, and only about 5% is the ordinary matter that makes up stars, planets, and us. In other words, everything we can see, all the wonders we admire, and all of human history is just a thin frosting on top of a cake made almost entirely of the unknown. Number 3. Dark matter, the universe's greatest magic trick. Dark matter is one of the most haunting mysteries in modern science, an invisible scaffold holding the universe together, yet forever hiding from our senses. When astronomers first mapped the motion of stars within galaxies, they found something impossible. The stars were moving far too fast. Based on the visible mass alone, galaxies should have been flying apart, their stars escaping into the void like sparks from a fire. But they weren't. Something unseen was providing the extra gravity needed to hold everything in place. That invisible something is what we now call dark matter, and it outweighs normal matter by more than 5 to 1. It doesn't emit light, it doesn't absorb it, it doesn't reflect it. It passes through planets, stars, even you, as though everything we know is made of fog. Dark matter interacts almost exclusively through gravity, shaping the cosmic landscape while remaining fundamentally undetectable by ordinary means. If we could see dark matter directly, galaxies would look nothing like the delicate spirals and islands of stars we admire. Instead, we would witness enormous dark halos of unseen mass that stretch far beyond the visible edges of galaxies. These halos act like cosmic wombs in which galaxies are born and grow. Without them, galaxies could not form at all. Matter would simply drift too loosely to clump into stars or planets. In a very real sense, dark matter is the skeleton of the universe, the structure upon which everything else is built. Yet despite its colossal influence, we still have no idea what dark matter actually is. It might be made of exotic particles that barely interact with our world. It could be a new kind of physics entirely, something that rewrites our understanding of gravity itself. We've built massive detectors deep underground, in the quietest places on Earth, hoping to catch even a whisper of these elusive particles. So far, we found nothing. And that silence is perhaps the most intriguing part. Dark matter is everywhere, shaping the cosmos and influencing the destiny of stars. Yet it remains stubbornly invisible. It is the universe's greatest magic trick, always present, never revealed. The more we search for it, the deeper the mystery grows. Number 4, the cosmic origins of your atom. Consider this. Every part of you, from the calcium in your bones to the iron in your blood, carries the signature of ancient stars. In the early universe, just after the Big Bang, there were no planets, no galaxies, only hydrogen, helium, and a whisper of lithium. These simple elements were the universe's raw ingredients, floating in vast cosmic clouds. It wasn't until gravity coaxed these gases into the first stars that the real alchemy began. Inside a star's core, unimaginable pressure and heat ignite nuclear fusion, the process that allows stars to shine. Under these extreme conditions, hydrogen atoms merge to form helium, releasing energy. As stars age and their cores grow hotter, they fuse helium into carbon, oxygen, and other elements essential for life. In massive stars, this cosmic furnace continues layer by layer, forging heavier and heavier elements: neon, magnesium, silicon, sulfur, and ultimately iron, the element that defines the limit of a star's strength. But creating iron is also a star's downfall. Once iron forms in its core, the star cannot extract energy from fusion anymore. It grows unstable, collapses under its own gravity, and then releasing more energy in a single instant than our sun will emit in its entire lifetime. It explodes in a supernova. A supernova is not just destruction, it is creation on a galactic scale. In that violent moment, temperatures skyrocket to levels where even heavier elements, gold, platinum, uranium, are forged. The explosion hurls these elements into space, scattering them across countless light years. These stellar ashes drift through the galaxy, mixing into new clouds of gas and dust. Over millions of years, those clouds collapse again, forming new stars, new planets, and eventually, life. So the carbon in your DNA, the oxygen you breathe, the iron coursing through your bloodstream, all were born in the heart of a star that lived and died billions of years before the sun existed. You are, in the most literal sense, a descendant of stars. Your body is a mosaic of ancient cosmic debris, recycled through generations of suns. Number 5, black holes, the cosmic engines within. But stars are only the beginning when it comes to the universe's most extreme architects. At the core of nearly every galaxy, including our own Milky Way, lurks a supermassive black hole, a titan of gravity millions or even billions of times more massive than our sun. Their very existence is mind-blowing, a place where matter is crushed to a point of infinite density, where space-time bends so violently that not even light can escape. Yet despite their reputation as cosmic destroyers, supermassive black holes play a surprisingly creative role in shaping the universe. Far from being giant vacuums devouring everything in reach, these black holes influence their galaxies on a colossal scale. As gas, dust, and even stars spiral toward them, the material forms a swirling accretion disk, a cosmic whirlpool heated to millions of degrees. This disk becomes so luminous that it can outshine the entire galaxy around it. When supermassive black holes pull in lots of matter, they ignite into quasars, some of the brightest objects in the universe. But their influence doesn't stop at light. As black holes feed, they also unleash astonishing jets of energy, streams of charged particles blasting out at nearly the speed of light. These jets can stretch across intergalactic space, sculpting the formation of stars, regulating galactic growth, and sometimes even halting star formation altogether. In this way, supermassive black holes act as both creators and gatekeepers, controlling the evolution of entire galaxies. Supermassive black holes are not just voids in space. They are engines of cosmic transformation, warping space-time and sculpting the universe on scales almost too enormous to grasp. They remind us that the cosmos is not simply vast. It is wild, powerful, and deeply interconnected. Number 6. When gravity warps time, time does not flow the same for everyone. We tend to imagine seconds and minutes as universal, constant, unchanging. But Einstein shattered that illusion with his theory of relativity, revealing that time itself is flexible, elastic, and profoundly shaped by gravity. According to general relativity, the stronger the gravitational pull in a region of space, the slower time moves. This isn't a metaphor. It's a measurable, physical reality. On Earth, the difference is tiny but real. A clock sitting on a mountaintop experiences slightly weaker gravity than one at sea level, so it ticks fractionally faster. If you spend your whole life in the mountains, you will actually age a few microseconds more than someone living at the beach. But when we move beyond Earth, into the realm of black holes, the effect becomes unimaginably dramatic. Near a black hole, gravity warps space-time so intensely that time slows to a crawl. To an outside observer, someone approaching the event horizon, the point of no return, would appear to move in slow motion, their seconds stretching into minutes, then hours, then infinity. From their perspective inside the intense gravitational field, time would seem normal, but the rest of the universe would race ahead. What feels like a few minutes to them could be years, decades, or even centuries passing in the wider cosmos. This phenomenon, called gravitational time dilation, means the universe doesn't just bend space, it twists time itself into extraordinary shapes. Time can stretch and warp depending on where you are and how fast you're moving. Even astronauts on the International Space Station, moving at high speeds and experiencing slightly weaker gravity, age just a bit more slowly than people on Earth. Number 7. Echoes of the Big Bang. Perhaps even stranger than warp time or invisible matter is the cosmic microwave background, the oldest light in the universe, a faint but omnipresent glow that fills all of space. It's not bright like starlight. In fact, it's microwave radiation, invisible to human eyes. But with sensitive instruments, scientists can detect this ancient afterglow, a soft echo left behind from the moment the universe became transparent. To understand its significance, we have to travel back 13.8 billion years to just after the Big Bang. The early universe was incredibly hot and packed so tightly with matter that it looked like a glowing fog. Light existed as tiny particles called photons, but they couldn't move freely. They kept crashing into electrons, bouncing around endlessly. It was like trying to see through thick smoke of a fire. Everything was opaque and unimaginably bright. But as the universe expanded, it cooled. After about 380,000 years, temperatures dropped enough for electrons and protons to combine into atoms. Suddenly, light was no longer trapped. Photons could at last travel freely through space. The very first light to escape that cosmic fog is what we now detect as the cosmic microwave background, stretched and softened over billions of years as the universe expanded. It is astonishing to realize that by studying this faint glow, we are reading the universe's earliest written record, a message preserved across nearly 14 billion years of cosmic evolution. Hidden within it are clues about the universe's age, shape, composition, and fate. It tells us how fast the universe is expanding, how much dark matter and dark energy exist, and even how the universe might have behaved in its first fractions of a second. Number 8. The silent end of time. And while the universe began in a blaze of unimaginable heat and brilliance, its distant future may be the opposite: cold, empty, and silent. The cosmic drama that began with the Big Bang may end not with an explosion, but with a long, slow fading into darkness. A scenario scientists call heat death. To understand this fate, imagine the universe as an enormous engine that has been running for billions of years. In the beginning, everything was hot and energetic, particles racing at incredible speeds. But as the universe continues to expand, and it will continue likely forever, that energy spreads thinner and thinner. Stars, the great engines of light and heat, will eventually burn through their fuel. Even the most massive, long-lived stars will one day flicker out. In a future hundreds of trillions of years from now, star formation will cease entirely. Galaxies, once vibrant with brilliant clusters of suns, will become quiet graveyards of cooling remnants, and black holes swallowing whatever strays too close. With expansion carrying galaxies farther apart, the night sky itself will grow emptier as other galaxies slip beyond the cosmic horizon, disappearing from view forever. Billions of years later, even black holes, the universe's most enduring structures, will begin to evaporate through a process called Hawking radiation, shrinking until they vanish in the faintest whisper of energy. What remains is a universe filled with cold particles spread so thinly across space that interactions become exceedingly rare. Temperature approaches absolute zero. Time stretches on almost meaninglessly. The cosmos becomes a vast, dark ocean of nearly nothing. We are living in a time when the universe is young enough to be vibrant, yet old enough to contain the elements needed for life. In the grand sweep of cosmic time, this moment, our moment, is brief, fragile, and extraordinary. Number 9. When stellar corpses come alive. Even today, the universe is anything but peaceful. Scattered throughout the cosmos are neutron stars, the ultra-dense remnants left behind when massive stars explode as supernovae. These objects are among the most extreme creations in nature, so dense that a single teaspoon of neutron star material would weigh about 1 billion tons on Earth. Imagine that, the mass of a mountain compressed into something the size of a sugar cube. Neutron stars are only about 20 kilometers across, roughly the size of a city, but they pack more mass than our sun. Because of this incredible compactness, they spin at astonishing speeds. Some rotate hundreds of times per second, sweeping powerful beams of radiation into space like cosmic lighthouses. We call these rapidly spinning neutron stars pulsars, and they keep time with such precision that some are more accurate than atomic clocks on Earth. Their magnetic fields are equally fascinating, trillions of times stronger than Earth's. The most magnetic of all, called magnetars, possess fields so powerful they could distort atoms, rip apart molecules, and, if one were somehow placed halfway between the Earth and the Moon, wipe every credit card on the planet. These fields are the strongest known in the universe, second only to the moment just after the Big Bang. But neutron stars reveal their most dramatic side when they collide. In rare violent events, two neutron stars spiral toward each other in a gravitational dance that can take millions of years. When they finally merge, they release more energy in a single second than the sun will emit over its entire lifetime. These titanic collisions forge some of the universe's heaviest elements: gold, platinum, uranium, and more. Every ring of gold on a finger, every platinum computer chip, traces its origins back to a cosmic cataclysm that shattered the quiet of space. Neutron stars remind us that even in a cosmos trending toward darkness and silence, there remain pockets of unimaginable power, stellar corpses that spin, blaze, collide, and reshape the elements that make worlds. Number 10, are we alone? And finally, we arrive at perhaps the most humbling and thrilling fact of all. We are almost certainly not alone. Not because of science fiction or wishful thinking, but because of the overwhelming mathematics of the cosmos. The universe contains an estimated 1 sextillion planets. That's a 1 followed by 21 zeros. It's a number so large that if you tried to count each planet 1 per second, you'd run out of time long before you even scratch the surface. Among these worlds are planets orbiting every kind of star imaginable. In our own galaxy alone, there are likely tens of billions of Earth-like planets and possibly hundreds of billions more in environments we can barely imagine. But the true wonder lies in the statistical inevitability. If just 1 in a billion planets harbors life, the universe should be teeming with living worlds, ecosystems evolving under alien skies, oceans filled with unfamiliar creatures. And if intelligent life has arisen even a handful of times across cosmic history, there could be civilizations older and more advanced than ours by millions or billions of years. The humbling truth is that humanity is incredibly young on the cosmic timeline. We have existed for only the tiniest fraction of the universe's lifespan. There has been plenty of time for life to emerge, flourish, and evolve elsewhere, long before Earth's first microbes ever appeared. And there you have it, 10 awe-inspiring truths that remind us just how strange, beautiful, and mysterious our universe really is. And the most incredible part? We're only at the beginning of understanding it. If these facts stirred your imagination or left you hungry for more cosmic wonder, then don't forget to like, subscribe, and turn on your notifications so you never miss another journey into the vast unknown. There are countless secrets still waiting out there in the darkness, so stick around. The universe has so much more to tell. Thanks for watching, Orbit Crew. We'll see you on the next mission.